All right, welcome everyone. Thank you for choosing to be with us tonight as we take a deep dive into the journey of a web request. I can see there's a few of us on here, so we're going to be starting right on 7 p.m. here in Melbourne. Okay, so before we actually get into the presentation of tonight, let's have a few words about jracademy. Some of you may already know about jracademy, some of you may not. So I'm just going to quickly introduce who jracademy is. jracademy offers training, offering bootcamp in the full stack space, the DevOps space, in a lot of the IT space, but also internship opportunities, job referrals, and interview guidance to really help you essentially really get your career to the next level, okay, and landing your job in IT. So our courses are taught by instructors from top-tier companies like Atlassian, Google, Amazon, and others as well. And our intention is that you come away having gained real-world experience. And on top of that, we offer career coaching to set you on track to fulfill your career goals. Now, we got about 10,000 plus active members in our community, and we have a lot of connections with companies or corporations in Australia and around the world. We're looking at 500 plus in-depth collaboration with 500 plus companies at jracademy and 200 plus networking opportunities with 200 plus corporation. And we're looking at companies like Amazon, Alibaba, Canva, Google, Amazon, and the likes. If you want to find out more about jracademy, feel free to take your phone out and scan this QR code, and you'll be able to get more information about it. I'll give you a minute to do that, and then we'll go straight into the presentation of tonight. Now, I'm conscious I haven't introduced myself yet. I'm Karel, and I've been the lead for product engineering, cloud engineering, DevOps engineering at leading companies like ANZ, REA, MOAB, and others. I'm also a certified cloud engineer. And previously, I was a Linux trainer at different universities back home in Reunion Island, but also in China. And I'm also a 3-time startup founder as well. I got a few businesses that I'm running on the side for myself as well that you won't hear about tonight. So, but before we get into it, though, I would like to let you know, if you got some questions throughout the night, the chat is open. Feel free to post your question in there, and I'll try my best to get onto your question to make sure it's answered so that you can get the best value out of tonight for yourself. So first of all, though, why is it important to understand what happens when you type jracademy.com.au in your browser or google.com in your browser? Why is that important? It's because, first of all, it's a very common interview question. Many companies use this as the base of starting an interview with a potential candidate. And it's designed in a way that allows you to demonstrate your breadth and depth of technical knowledge. It's open-ended by design so that it allows a conversation to unfold, and you really get to show how well you can communicate technical ideas and concepts and how much you know about them. Now, given how broad and deep this can actually go, it really sets the foundation for the interviewer to be able to dive deeper in several different topics and ask you questions to understand really how much do you know about the topic. Now, look, the reality is we only got an hour tonight, and really it's not going to be enough to be able to cover everything. But my intention tonight is that you walk away having enough knowledge that you can go and dig deeper in the topics that are related to a web request coming from your browser and going into the server for you to be able to show a web page showing in the browser. Okay, so today we're going to be spending a little bit of time in the browser because this is what we're going to be talking about today. And so first of all, let's talk about the developer tools. Does any of you know about developer tools? Feel free to answer in the chat. Any of you have used the developer tools before? What I'm going to be doing with that is I'm just going to quickly show you, for those of you who maybe I never heard of Developer Tools, the Developer Tools is a place for you to be able to really find out what happens in your browser in terms of what happens when the HTML gets presented in your browser. What are all the different network requests that are made when you actually go into a website? And we're going to be using jracademy here, .com.au, as an example tonight, okay? So if we're going to inspect, that's going to open the Developer Tools here on the side of the actual web page, and we're going to be focusing on the network tab. If I actually quickly click a refresh, I just want to show you quickly that there's so many things that actually happen when you type in jracademy.com.au. It's not just magically a page appear here. There's actually a lot of many requests and processing that actually happen for it to show up. Like you can see here, there's so many different pages, scripts, documents that are loaded for you to be able to have this page. And that's what we're going to be focusing. That's where we're going to be spending a bit of our time tonight. Okay. So going back to the presentation, first of all, what actually happens when you click and you type in jracademy.com.au? Well, first of all, there's a DNS request that actually happens. What is DNS? DNS, it stands for Domain Name Service. It translates human readable names into IP addresses. And the way you want to think about that, you want to think of it like a phone book. When you go and call somebody called Joe, for example, one of your friends called Joe, you often would not go and type in the number of Joe, right? If you have it in your phone book, you just go in your phone book and click on the name Joe. And what your phone does in the background, it translates the name Joe that you have in your phone book to the actual number that is linked to it. And the phone actually dials the number, not the name. If you think of it this way, on the internet, for my computer to be able to find another computer, it needs an address, a way to be able to get there. This is what the IP address is. But if I had to remember the IP address of every single million or billions of servers that are out there on the internet, I would have a really hard time to just open a web page. Hence why DNS is here to really make it easy for us to be able to translate the name jracademy.com.au to an IP address. Now, as I said, tonight we only got an hour, so I will be going a little bit basics, but you'll have the opportunity to ask more questions if you want to dig deeper into a topic, okay? So feel free to use the chat anytime that you need. Now, what really happens, the process that actually happens in your browser is when you type in the name, the browser tries to find out, hey, do I know what this name translates to? If the browser doesn't know that, the browser is going to ask your operating system, Mac OS, Windows, Linux, and ask it, hey, do you know what does jracademy.com.au points to? If the OS doesn't know, then the OS is actually going to go out there on the internet and asking on the internet, making a DNS request, it's called, to be able to resolve the name to this IP. Now, that resolution, we're not going to get into it today, but that is quite complex. What happens here, there's actually multiple servers that are involved in being able to just find for you what jracademy.com.au points to. And then you get the response. Now the browser knows about the IP, and now the browser can actually send a request into the IP. Now, in an interview, you may have the interviewer asking you, well, okay, you know DNS, but what else can it do? Can it just do human readable names into IP addresses? Well, the reality is that it does a lot more than that. There's things called DNS records, which are essentially that mapping that we just talked about. For names to IP addresses, we're looking at the A record. There's other type of records in DNS. You got the C name, which points a name to another name. We got the MX record, which when you send an email out to joe@jracademy.com.au, what actually happens is that the server that sends that email needs to know where does that email need to go, okay? And that MX record is what allows you to be able to find out which server on the internet is responsible to receive the emails for jracademy.com.au. The NS record is those records we're talking about, the A, the C name, the MX. This needs to live somewhere. And that server needs to be able to let other people advertise itself to know that I'm the person, I'm the server who knows about all the records in this domain. And that's what that NS record is for, is to be able to specify which server is the authority, is responsible to knowing what is the true response, what is the true record between this name to this specific IP. And the last one that I just want to talk about, and this is not an exhaustive list, by the way, is the TXT record, which is a text record, which just holds some arbitrary text information in DNS, and it's often used for domain verification, for security, etc., etc. Now, all of those records have something in common. And this is called a TTL, a time to live, very important for you to understand in an interview. A TTL essentially is, remember how we talked about browser cache and OS cache, etc., etc.? Well, that browser cache, it cannot cache the record forever. If it did cache this record forever, what's going to happen for the people who use that browser and who tries to go to jracademy, if jracademy decides, instead of hosting my servers over here, I now want to host it over there. So the IP address is going to change. If this is cached forever in the browser, cached means that the browser keeps a copy of it. What's going to happen is that you're going to go to this place here where jracademy does not exist here anymore. So somehow the browser needs to know that jracademy is not here anymore, but it's over here. And this is done thanks to TTLs. So the browser will know I can only keep this record into my cache, into my copy for 60 seconds, for 5 minutes, for 1 day. After 1 day, I need to revalidate what the mapping actually really is now, if it has changed or not. So this is what the TTL is. The TTL is to be able to advertise to everybody that this name here, you should keep it only for X amount of seconds. Now, there's a few commands that you can use, and often, again, in an interview, they may ask you, well, now I got my DNS set up, but I'm having some issues. For whatever reason, jracademy.com.au, when I type it in the browser, it's telling me that the DNS is not resolving to a server. How can you troubleshoot those things? What can you do now to be able to find out what could potentially be the reason why this is happening? Well, there's some commands for you to be able to verify that. You got NSLOOKUP, you got dig, you got, I'm sorry, just behind my screen, you got ping, and you also got whois that allows you to get some information about the DNS. If we look at dig and NSLOOKUP, they're really here to be able to resolve DNS. For example, you would do something like dig jracademy.com.au and it will give you the IP for jracademy.com.au. But whois is a little bit different. Whois is for you to be able to find information about who owns the domain. Let's say, for example, there's a domain you want to buy. I'm just going to make that up. jruniversity.com.au. Let's say jracademy wants to buy this new domain, but this domain is taken by someone. What you could do a whois to find out who actually owns this domain, so that now jracademy could speak to that person to say, hey, I would love to buy this domain off you. It's also great for a lot of other reasons, to be able to know where it's hosted, etc., etc. But whois is not to be able to resolve the DNS to a name. It's really to find information, metadata about that domain. Okay, so that's DNS resolution. Feel free to post in the chat again if you got some questions about that. Now we're going to move to the next thing. Now the browser knows where to go, which server to contact for jracademy.com.au. So what does it do? What is the first thing that it actually does? Well, first it needs to establish a connection. Now, when you actually try and connect to a server, it's not a direct connection. It's not my computer connecting to that server directly. That would be way too easy. If you think about it, if you're in Australia and you're trying to fly over to Paris. You're not flying directly from Australia to Paris. You may fly through Shanghai, and then from Shanghai, you may fly to Frankfurt. From Frankfurt, then you may fly to Paris. So there may be multiple points that you'll be stopping at to be able to get there. Or you may have a different route altogether. You may be flying from Melbourne to Sydney, Sydney to New Zealand, New Zealand to LA, LA to Paris. So there's multiple routes for you to be able to get to the destination. This is what we're talking about here. It works exactly the same for a request for my client to be able to connect to the server. That request that I'm sending may take different routes to be able to get there. The different points, the cities that you stop in when you fly. For an internet request, this is called a router. So my request may stop at my ISP router, ISP for my internet service provider, stop at my ISP router. This request may stop to another router, and then the best efficient path is going to get me to the server. Now, once this request gets there, what happens is that my browser, also called the client, and the server, they need to agree to communicate. It's like you're going on the street and you're trying to engage in a conversation with someone. You kind of need to acknowledge each other to be able to have that conversation, yeah? So it's really the same with on the internet. Is the browser is going to say, hey, I'm going to send you a SYN, a request for synchronization to the server. The server may say yes or no. If the server says yes, it's going to say, I got your SYN, I acknowledge your SYN, and I'm going to send you as well a request for synchronization. So the browser will send a SYN, the server will send a SYNAC, and now the browser will be like, okay, great. You're happy to talk? Now let's talk. And so the browser then will send an acknowledgement back to the server, and that will essentially open that channel of communication between the browser or the client and the server. And this is called the three-way handshake. I cannot tell you enough how many times I got asked this question in an interview, where they asked me, can you please explain the three-way handshake? So you really want to understand that. Again, you can research a lot more afterwards about, what it is, how it works, etc., etc. But just remember this word, the three-way handshake means that the three requests that happen to be able to have that handshake between the browser and the server for them to start their communication. Now, when you have a communication, and I know some of you may know that already, so apologies if that's a little bit basic, but just to go over that, and maybe it will give you another way, another perspective to it, is when I connect from my browser to the server, I don't just connect to the server, I connect to a certain port on the server. Vijay, did you have a question? No problem, all good. So you connect to a certain port on the server. What is a port? A port is kind of like, if I got a house, I may have multiple entries into my house. I got the windows, I got the doors, and some of them will be closed, some of them will be open for me to get into. And that door, it works exactly the same for a server. It's kind of like the server has multiple doors. Some of them are closed, some of them are opened. And you connect into that door to be able to establish that connection. And the port that are used, often people may ask you that as well in interviews, are port 80 and port 443 when we're talking about web connections, when we're talking about HTTP and HTTPS. So HTTP will be on port 80, HTTPS will be on port 443. I will look a little bit more into that secure connection, that HTTPS connection afterwards as well. So if you wanted to be able to debug the connection to the server to that specific port, whether that's port 80 or port 443, there's some commands that you can use on your in your command line on your OS to be able to diagnose it. And you got telnet, which allows you to make a connection to a port. You got trace routes, which actually allows you to trace which route the packet is taking to be able to get to the server. And you also got TCP dump. Now, TCP dump is a bit of a different one. TCP dump is for you to be able to get a dump of every single network request that are actually happening on your computer. Okay, So I will be able to see, for example, the scene, CAC, and ACK going through in TCP dump. Okay. Now, again, we're not going to go into those commands and how you use them. This is just for you to be able to get enough breath so that you can go and keep on researching for yourself. Okay, so that's the initial connection. So we got the DNS resolved. I know the IP. I'm now connected to the IP. I got that connection happening. Now, if there was an HTTP connection, so on port 80, an HTTP connection, so in plain text, when people say plain text, this means it's non-encrypted. Okay, so there's no encryption. Anybody on the internet, if they were listening to these communications, they will be able to actually see in clear text what's really happening. Okay, so you won't see gibberish. If you are sending, for example, I don't know, like a message to your girlfriend that is over in the US saying, I love you, people will be able to see it on the internet that she said, I love you to his girlfriend. Okay, so that's what non-encrypted means. So when we actually looking at the initial connection, I got my connection here, but we want it to be secure. Why? Because it protects us, protects our data, and protects any, maybe potentially your bank credit cards as well, protects this information as well, right? That's why it's security, having the channel being encrypted is very important. So can I just connect directly and start sending information and start sending my request for the website, etc. on that connection? You could, but most websites nowadays, they actually send on port 443. Most of the website, they only do a redirect from 80. So if you try to connect to 80, it's going to tell you, yeah, that's great, but I want you to connect on this one instead. Okay, and we'll look into that afterwards. So how does that happen? How does that encryption actually happen? First of all, this is what now we're talking about a TLS and SSL handshake. This is kind of me, for example, talking to my friend over in France and telling him, hey, I want to talk to you, but let's talk a language that nobody in the world can understand. Only you and I can actually understand. And the way that works is that, first of all, the client and the server, they need to agree on what are we actually going to be using to encrypt this information. So first of all, now that we got that initial connection done, the client is going to say hello to the server. The server is going to say hi back. It's going to send back its certificate. So a certificate of identity. This is kind of like your driving license that proves who you are. So the server is going to send back its certificate, and it's also going to send back, hey, I can speak those encryption languages to make sure that our communication is safe. The client verifies that the server is indeed the server that it says it is. And then they start to exchange the key for encryption. So before the client sends any data to the server now, the client will first encrypt that data, send it to the server. The server will get that encrypted data. Nobody in the middle will be able to read it because it's gibberish to them. The server will then decrypt this information, do whatever processing it needs to do. And then before sending information back to the client, it will encrypt it again, send it to the client, and the client will decrypt it. If there's any issues you may have with certificate, usually the browser is enough to be able to work that out. We'll have a look into it later if we got enough time. But you can actually, on the command line, you can also troubleshoot certificate. For example, a certificate may expire. A certificate is only valid for the many years that you buy it for. Maybe for 1 year, maybe for 5 years, maybe for 10 years. Usually it's for 1 year nowadays. So that certificate may have an expiry on it. That certificate is only valid for specific domain names as well. So it will not be valid. If I have a certificate for jracademy.com.au, it's not going to be valid for google.com.au, right? That's the identity. Remember, the certificate is like your driving license. I can't give my wife my driving license and say, you can now drive with that. It's exactly the same. Google cannot give JR Academy, here's my certificate, and tell JR Academy, now you can run with it. It's not possible, okay? Because that's your identity. So OpenSSL is the command that allows you to debug and really just trying to work out why your certificate may not be working as you expect it to be, as OpenSSL will be able to grab you a lot of information. Now, a lot of that information, like I said, you can get that from the browser, but in an interview, they may ask you, how would you find out whether a certificate is expired or not? Well, you could answer, I would go in the browser, or you could also say, well, there's a command that allows me to do that, and it's called OpenSSL. Okay, now I'm going to stop for a minute. I've spoken a lot. Does anybody have any questions on what we've discussed so far with the initial connection, the DNS, and the TLS and SSL handshake? Okay. Don't be shy. There's no stupid questions around here, okay? This is for you, so really don't be shy. Okay, so let's go to the next one. Now I got my encrypted connection happening. I'm good now. I can connect to the server. I can send my information securely. The server can respond to me securely. I don't have to be afraid that people are going to be able to get my information. I'm good now. So now I can talk. Now I can actually request the resources that I need from that server. And for a website, for the web, the protocol that is used is HTTP. Now, HTTP for Hypertext Transfer Protocol, and HTTPS is just a secured version of HTTP. So it's just HTTP running within a TLS SSL encrypted channel, okay? Now, what is a protocol, by the way? Some people may see, oh, it's a protocol. Yeah, what does that actually mean? If you like, a protocol is kind of like an agreement of how we're going to be exchanging information. For example, we talked about DNS before. If you wanted to make some DNS queries, there's some DNS requests. This is going to be talking the DNS protocol. Now, if I want to be talking about the web, I want to be able to get some images from the web. I want to be able to get some index.html, so some web pages, some CSS, some JavaScript from the web. This is going to be talking HTTP. Okay, so this is the agreed language. This is a language that's been invented that everybody uses for the web to be able to transfer information on the web. Okay. Now, the way that it's done, so like I said, we're talking about the language here. So in language, there's verbs, and there's different verbs for you to be able to execute a specific operation or a request between the client and the server, right? When you actually get https://jracademy.com.au, what actually happens is that your browser is telling the server, I am getting. This is a GET request. This is called a method, by the way. I want to get index.html from you. And then the server then knows, oh, you're trying to get something? Cool. I'm going to get that, and I'm going to send it to you. But there are times where I want to be able to submit data to the server. For example, if you're building a to-do list app, you may be adding a to-do into your list. To be able to add the to-do, you want the server to be able to save that. You want to post some data over to the server, and you're telling the server, I'd like for you to create this data on your side. I want you to process that. That's why this is called a post method, where you're posting some data over to the server. Now, let's say you go to to-do now. You just created it with the post method. You want to be able to update it. For example, I finished the task. I completed it. I want to check it up, right? Check it out, right? Now, to be able to update this resource, you may be using a put request to the server. So you, from a application or web application, you'll be sending a request to the server, a put request to tell it, please update this resource, this to-do on you, okay? Now, as part of that, if we just look at get this post that, put this. That's not a lot of information for the server to work with, right? There's other things that are sent with it. There's headers, which are like metadata, additional information that are attached to a request being sent to the server. For example, the server likes to know who's asking me all those things. So the browser will be sending a user agent. This is the name of the header. And we'll look into that afterwards when we do a bigger demo in the developer tools. But the user agent will contain the information about the browser. So the server will know this is Mozilla Firefox, this is Edge, this is Chrome, this is Brave, whatever browser that you use and which version it uses as well. Okay. There's another header called host. This server may be serving many different websites. It may be serving jracademy.com.au, but it may be serving, I don't know, I'm just going to make that up again, jruniversity.com.au. So the server needs to know which website do you want it to actually serve it back to you. Hence why there's a host header that basically is the domain name that you type into your URL in your address bar in your browser. That domain name is sent as well as a host header so that the server knows that you're trying to access this specific website. And then you got the content type. And those are just, by the way, those are just common headers. This is not the full list of headers. There's so many more headers that we won't be able to get into today. But the content type is the type of data that you're trying to send to the server. Maybe you're trying to send an image. So the server needs to know how to handle it. So the server wants to know what is the content type. That's why the client will tell the server, I'm sending you an image, or I'm sending you just some data, some text data, or as I'm sending you a zip file, just so that the server knows how to handle it. Now, if you wanted to be able to access a web server from the command line, why would that be useful? It's because often in jobs, you may be asked to be able to download a page or download a specific file and put it locally onto a server. And on that server, you may not have a browser. So how you would do that, you will use the command line. And there's two main command lines that you can use to be able to access a server on the web. Those are curl and wget. Okay. Again, very important to know that connecting to a server on the web is not only done by your browser. In fact, I dare say that most of the requests on the internet that's happening are not happening from a browser. Okay. Okay, so now that's HTTP, that's HTTPS. Just a quick reminder here, HTTP is on port 80, HTTPS is on port 443. Why I'm reminding you of that, because it's really important to understand. You may be asked that at interviews, okay? I know for my very first interview that I had, my very first job, they asked me every single port of many different protocol, like what is the port for mail? What is the port for DNS? What is the port for HTTP, HTTPS? So back in those, and that's 20 years ago, back in those days, we really needed to know that. Today, maybe not as much, but HTTP and HTTPS is critical to know, okay? Now, I've sent a request to the server. We're speaking the same language, and it's all encrypted. Now the server can do what the server needs to do. For example, I send a request to create a to-do in my list. The server takes that request and can decide according to who you are, whether or not it's going to do it, whether or not it can do it, whether or not your request is valid, or whether or not it will be like, well, you're trying to connect to me, but actually I'm not the one you should be connecting to. You should be connecting over there. So there's ways that the server actually tells the client about that. Sometimes the data that you request is available. Sometimes that data is not available. For example, as any of you try to go on a website, trying to type in let's try here, right? I tried to type in maybe not jracademy. Let's just go to google.com, right? And I tried to go to google.com, blah, 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 blah. That's giving you an error. It's not actually giving you like proper data, the data that you requested, right? And you're getting what is called a 4.4. I'm sure many of you have stumbled onto 4.4, not found before. This is called a status code. If we quickly go back to the presentation here, you'll see that this status code is essentially the outcome of a request that you're making to the server. There's many type of status codes, many families of them. You got the 200 family, which is usually the success. So it worked. Often a 200 OK. You may have a I accepted your request, which would be a 202, etc., etc. You got the redirects in the 300s. Essentially, you're trying to go to google.com.au and google.com.au is telling you, don't come to us, go to www.google.com.au, for example. Or even better, you're trying to connect to google.com.au on port 80, so HTTP, and Google is telling you, no, I want you to go on my port HTTPS, so port 443. So it will use the 300 family to let the browser know that I want you to redirect somewhere else, okay? The 400s are the client errors. This may be things like, for example, I'm sending some data, some zip file to the server, but the server is like, I don't accept the zip files. What are you sending to me? So it will send you back an error and say, you client, you're crazy. You're sending me data that I can't deal with, okay? And then you got the 500s. And the 500s are the server errors. For example, the code on the server may be buggy, right? It may not work and it may crash. So the server will send a response back to the client saying, 500, I got an internal server error. You might have seen that as well. I got an internal server error. I can't deal with it. Now, there's nothing for you to change in your browser. It's nothing to do with your browser or the data that is sent from the browser to the server. Is that the server has potentially some issues. Maybe the server is overloaded as well, getting way too many requests. It will also send back a 500, something from the 500 family. Now, we spoke about request headers before. So the headers that you send when you make a request. There's also response headers. So the server may respond with some information as well. Again, we've got the content type here. So to be able for the server to tell the client, this is the type of data that I'm sending you. We got the content length, which is the size of the data. We got the cache control, which we'll talk about a little bit more after, which is how do I want you, browser, or maybe the other servers that may be between you and I, to be able to cache that data, to be able to keep a copy of that data. Okay, and we'll talk about that a bit more after. And then you got the location header. Location header is if we have a redirect, which we talked about just before, is how does the browser actually know where to redirect to? Well, the browser will actually find that information in the location header. So again, there's many more headers. We won't be able to get into them today. Okay. Okay, so that's the server response. So now I got the server response. The response is back onto the browser. What does a browser do? So for example, I've typed in jracademy.com.au. The first thing that I'm going to get is the index.html. The index.html is essentially what's going to tell me what is needed for me to be able to show that page, that web page on the browser to the user, okay? So what actually happens? Well, there's browser rendering. When people say rendering, what is it talking about? They're essentially talking about painting or drawing the visuals on your browser, okay? That's what the rendering is. Now, first of all, you'll receive the index.html. Now, the index.html, if you've never seen what it looks like, that's what it looks like right here. Right, so it's essentially what is called an XML file, which contains a lot of information about the web page and how the web page should be printing out, right? But in here, there will be other information, and there will be other information like, for example, the styling, those colors that you got on the page, those the way that the shapes of the different boxes that are rounded on your page, right? This is all done through styling, also called CSS. Okay. Then you may have some interactivity happening as well, maybe some animation happening as well on your browser. Maybe when you click on this button, it triggers I don't know, an amazing fireworks animation. There are some scripting that happens in the browser to make that happen, which is done via JavaScript. Now, for the browser to know what to download, to be able to render the web page, the index.html will have that information. The index.html will say, for me to be able to be printed out properly, you need to go and get the CSS, you need to get that JavaScript as well. Now, CSS and JavaScript, this is very important for you to get. CSS and JavaScript can be blocking. And what does that mean? It means that it stops the rendering from happening in your browser. Let's say I got the index.html. We're not going to show some XML file to a user, right? We want to show a beautiful page. For that beautiful page to show up, the browser is going to need not only the index.html, but often if you have CSS, it will also need the CSS, okay? And if it needs in animation, it will also need the JavaScript as well. Now, if you absolutely need those to be executed before the user can interact with the page, this is called blocking. You want the rendering to be blocked. Now, the problem with blocking is that it delays anything showing up in the browser for people. Nowadays, we got really powerful computers. Back in those days, back in maybe even just 10 years ago, you would see a blank page for like maybe, I don't know, a few milliseconds before you actually see the web page. And that's because there was either CSS or JavaScript blocking it, or maybe it took a long time to actually download the files, right? Now, in the index.html, there will be also images that you may want to download, etc., to be able to show the user. So all that assets, this is what is called an asset. This is your fonts, your images, your videos, etc., etc. This will get downloaded as well. Now, as I was saying just before, the downloading can take some time, and the downloading can actually delay the moment that things can be shown to the user. So how can we actually accelerate all of that? There's many ways to do that. Tonight, we're going to be looking at one way. And one of those ways is caching. Caching, there's different type of caching out there. Today, we're going to be talking about browser caching and CDN. CDN for Content Delivery Network. Browser caching is very simple. Essentially, you open a web page for the first time, it downloads all of those things, but then the browser may not download everything again the second time you open it, because the browser now has a copy of the images, has a copy of the JavaScript, has a copy of the CSS, and doesn't need to go and load from the server anymore. So the first time may be slow, but the time after that is super, super fast. Now, what is a CDN? A CDN, Content Delivery Network, is a network of servers that companies like Amazon, Google, Akamai offers, or even Cloudflare, etc., if you heard of them, offers to be able to accelerate the delivery of your assets, images, etc., to the users. And essentially what happens is, if I'm trying to connect to a website that is in the US, for the time for my request to arrive to the US, it may take a bit of time, okay? It may take some time to get there, but then it will also take some time for the response to come back. So what companies have put in place is they put in place a content delivery network where they have servers all around the world that actually holds copies of various websites out there, okay? For example, if I go to google.com.au, I'm actually not connecting most of the time connecting to a server in the US. I'm often connecting to a CDN, that is a server that keeps a copy of the website, and I'm simplifying that a little bit here, keeps a copy of the website, and that server is most likely either in Melbourne or in Sydney. So because it stays in Australia, it's really, really, really fast, okay? Now, if Google were to make some changes on their website, they probably would want those changes to appear on those servers that are close to you as well. Otherwise, you won't be able to show those changes on your browser. So hence why the CDNs, usually what they do is, I want you, server, to tell me when I download the file from you and then copy it on my local disk. I want you to tell me how long should I keep it locally. And we talked about the cache control before. The cache control is one of the headers that really allows for the CDN to know how long it should be keeping this resource locally before trying to fetch it again. And it's also used by the browser for the browser to know how long I'm going to keep this resource, this image stored locally before I ask it again on the network. Okay. And there's also last modified, which basically says from a server perspective, this file here that you're asking me was last modified, let's say 4 days ago. So let's say, for example, me as a browser, I'm asking for a file, and now I'm asking again. Now this file could be 2 gigabytes that I'm downloading. Rather than downloading the same file again, the server is going to tell me, hey, you know what? I've last modified this then. And the browser is going to check, oh, actually, I downloaded it after that last modified, so I'm not going to download it again. Yeah. Cool. Again, if any questions, feel free to go and ask. Now we're going to get into our demonstration. We're going to get into the browser. We're going to be looking at what actually really happens when you tap the URL in your browser. And what we're going to be looking at for that, we're going to be looking at the jracademy website. Now, like I said, this is the developer tools. Please let me know in the chat if it's not big enough. I can make it bigger if needed. I might just make that one bigger for now. So let me know if you need me to change anything here. So when I actually go, let's try that again. If I refresh this page here, you'll see that there's so many things that are downloaded. Now, the first thing that you see here is this timeline. This is called the network timeline, but it's also called the waterfall or the network waterfall. Okay, people use that word. This may come out in an interview, and they may ask you, so what actually happens when I type it? Does everything get downloaded at the same time? No, there's actually a waterfall of events that happen. There's a waterfall of network requests that happens for a web page to be able to show up with all the images, the style, the scripts, etc. And if we look here at jracademy, if I refresh here once again, the very first line that I got here is that index.html being downloaded. If you click on it, you'll be able to see the headers. Remember how we talked about the request headers? You can see the request headers here. There's a lot more than what we talked about. You can see here there's the response headers. Again, there's a lot more than what we talked about, and maybe some of them are not even here. And then you got the status code. Remember the not modified? We'll get into that in a minute, but if you look here, actually, I'm just going to show you that now. If I refresh it, but I refresh it without the cache, okay? So I refresh it, but I'm basically going to clear the cache that I got in my browser right now. Look at this. You can see here the size of it. It's 30 kilobytes. Now, if I refresh it again, and you can see the status code is 200. If I refresh it again, and now I'm going to say refresh it, but use, the cache, right? What's going to happen? It's going to ask it again. But see, I'm only downloading 240 bytes. I'm only downloading 340 bytes because apologies for that, because the server only returned me a 304 not modified. Hey, this is not modified. You don't need to download it again. The version that you got, the version that you told me that you got is not modified. So I'm not going to send the data again. Just use the copy that you got. Okay. So here we already accelerated the download of this page. If you look at the bottom here, Again, if I do it without cache, you can see here, it took to finish, took 700 milliseconds to be able to load the whole page, right? If I do it now with the cache enabled, so now this caching, we're at 300 milliseconds. Okay, so you can see that really with caching, you can really accelerate the web. Again, back in the days, 10, 15 years ago, there were so many websites on the internet that would take 10 seconds to load. 10 seconds is unbelievably long for people, right? So really just having the cache really allowed us to make it faster. Today is still necessary, but pages nowadays are much faster than they used to be. Now, quickly going back on here, like I said, the very first one is downloaded. You can see if you look into the timing here, that's where you'll be able to see how long did he spend. Let's reload that again for a minute. How long did he spend doing the, let me use, that's fine. How long did he spend making the request? How long did he wait for the server to respond? Okay. And let me use another website because I think I got some stuff cached here just for a minute. Here we go. Now I don't have DNS cached, etc. for this one. So you can see that it's actually doing the DNS lookup. It's doing the initial connection like we talked about, the SSL connection as part of that initial connection, sending the request, waiting for the server to respond and downloading the content. Okay. All right, so that's the demonstration I would be doing in the browser for today. And we're not going to go much further than that. Now, I've got a few questions for you. But before we go into these questions, feel free to read it if you'd like to. But before we go into this question, I want to know, is there anything that you'd like me to go back to looking into the browser and looking at the network tab of the developer tools?
Well, hi, Karel. I have a small question for you.
Yep.
Can you hear me? Yep. All right. So for the could you go back to the previous slide, please?
Previous slide?
Yes. No, that's one. Oh, sorry. It's your demonstration. But anyway,
got it.
For the
yep.
304, yep. For the 304, not changed. Is that a standard criteria for every web page? I mean, if I follow a tutorial about next tutorial, I build one, and is that automatically applied in my simple website?
It's a great question. Very great question. So it depends on the server that you are using, Jason.
Yep.
So most servers will implement it that way. You're correct. Some servers may not. So if you use a common server, like for example, Nginx or Apache or any other kind of typical web service that people would be using, then yes, it will support exactly what we just did. But if you were to craft a server on your own, then it's on your responsibility to really follow those standards.
Yep, I got it. So it doesn't matter what tag you are using. It's about your server, which server you host your website. Okay, got it.
That's exactly right. Yep, great question. Thank you for asking. Anything else, anyone? Okay, so now we're going to play a little bit of a game. Okay, Yes, that's exactly right, Bruno. Thanks for mentioning. Yeah, so servers do not implement those conventions. And so yeah, it really depends on the server, Jason. Thanks, Bruno. I appreciate the contribution. Okay, now we're gonna play a bit of a game. Okay, bit of a quiz. Let's see who can get it right. Look, there's no right or wrong questions. One thing that you'll know, by the way, is when you are in interviews, often you get scared about, am I going to say the right thing? Often in tech, there's no right and there's no wrong. There's often it depends. It depends on the situation. It depends on the people. It depends on so many things for you to be able to get the most adequate answer. Of course, there's some answers that are just wrong. For example, what is the common port for HTTP? And you say 79. Well, no, that is not correct, right? But a lot of other things, a lot of other questions when you're talking about, for example, design and in the way that you implement it, etc. There's often no right questions. And what interviewers are looking for, they're really looking for the way that you're thinking about the question that they ask you and how you go about answering it. Okay. So I know it can be scary sometimes in interviews and you feel like you got to know everything. It's not. And I promise you, often the interviewers doesn't know everything either. Nobody can know everything. Okay. But I got some quiz. So let's have a quick look, right? So if you had a website and the static assets are not being cached, and when I'm talking static assets, I'm talking about your images, the scripts, they're not being cached by your CDN, your content delivery network. What impact might this have on the user experience? A, you get faster load times due to direct server access. So you don't have the CDN in the middle. You're connecting straight to the server. B, you got increased server load and slower page load time. C, you got enhanced security by avoiding cache storage. I got a lot of answers here. It's great. Keep them on coming. I'll give you a few seconds for people to think about it and read the question again if they need to. I'm surprised nobody picked C just yet. Great. Okay. Well, everybody's right. The right answer is B. You got increased server load. And why you got increased server load is because you don't have that server standing in the middle serving those static assets back very quickly to the browser. That means that now the server needs to be able to handle so many requests all at once. For example, if you look at google.com.au, they got, I don't know how many requests, but they would have millions and millions and millions of requests per minute, right? If not billions, I don't know. So if you look at it, if all those requests were going back to the servers, Google got a lot of money and they got a big infrastructure, so they may be able to handle it, but it will add a lot of load onto the server. And because of that, you have slower load times just because the server is busy, but also because the server may not be close to you, where the CDN is very close to you, right? That's the purpose of a CDN. So you will have slower page load time if your static assets are not cached by the CDN. Next one. What could happen if the TTL, time to leave, value of your DNS record is set too high? A, DNS changes like server IP updates may take longer to propagate. B, your website server might become overloaded. And C, users may experience a faster DNS resolution. We got an A from Abby. A for Ying. Okay. Well, A is correct. A is correct. Now, C is also correct, by the way. So this is one of those examples that sometimes, there's no right or wrong. C is also correct. Users will experience a faster DNS resolution because it all happens directly in the cache. But they may get the wrong response, but the resolution itself will be faster. But that's great. That's great. The right answer was A for this one. Good job, everyone.